Hey guys, it's off by one here, and today we're going to be solving merge intervals. In this problem, we're given an array of intervals where each interval tells us a start point and an end point, and they want us to merge all overlapping intervals, and in the end, we're supposed to return an array with all the intervals fixed so that they're not overlapping. Here I've drawn this example 1 here, and every single interval is plotted here on a number line, and as you can see, this interval here is overlapping with this interval here. So what they want us to do is merge these two intervals so that they're not overlapping. And the way to do that would just be to have a new interval that goes from 1 all the way to 6. And then these two intervals here are not overlapping, so our final result would just be an array that looks like this. Also, one small thing about this problem is that if our interval ends at the same point that the next interval starts, these are considered overlapping. So for this scenario here, we would just merge 1 and 4 and 4 and 5 into one interval, that is 1 and 5. So now that we understand the problem, let's get into the solution. So here I've redrawn the problem from the example, but as you can see, there's a small difference because the intervals are not sorted. And for this problem, we're not guaranteed that the intervals are going to be sorted. So that's something you have to consider when coming up with a solution. To sort the intervals, it will take O of n log n time. So before defaulting to this sorting solution, we have to ask ourselves, is there a faster way? And the answer to that would be no, because the only way to actually check if there's overlapping intervals would be to start from one interval and then check it against the other intervals. And if they are overlapping, then we would have to merge them. But this solution would take O of n squared time because we would have to have a nested for loop. So this tells us that the best way to approach this problem would be to start by sorting the intervals. So here I've sorted the intervals and they're sorted by start time, and you'll see why I did that in a second. But basically, when we're merging our intervals, we know that this first interval is going to have our lower start time. So let's start solving this problem. First, we know that we're going to have to compare two intervals at a time because that's the only way to check if there's an overlap. So we're going to have 2 pointers. And let's just initialize our first pointer at the start and our second pointer at this first index here. I'm going to call this pointer previous and this pointer current. So this pointer is pointing to the previous interval and this current one is whatever interval we're currently looking at. So now we start checking if there's any overlap between the previous interval and the current interval. And as we can see here, there is overlap. But how do we define that in our code? Well, we can see here that the previous point's end time is greater than the current start time. And that should tell us that there's overlap here. So we can say that if the previous end is greater than or equal to, remember that edge case where if they are at the same spot, then they're considered overlapping. So if the previous end is greater than or equal to our current start, then that means there's overlap. And if there's an overlap, we want to take care of that. We know that the interval that should come from these two being merged is going to be 1 all the way to 6. But how did we get this interval? Well, we took the start time of the previous one, because remember they're sorted by the start time, so we never have to worry about the second interval being less than the previous interval. And this endpoint is calculated from the max between the end of the first interval and the end of the second interval. The reason we want to check the end of the first interval is because the first interval can go all the way over here, let's say, and then this would be the max. And it could just be engulfing the second interval completely. Okay, so now we know that the interval that comes from these two being merged is going to be 1 and 6. And in our code, we're going to store this in a temporary variable. But for now, I'm just going to switch this to a 6 just to save some space. And then we're going to move this current pointer to the right. And we still can't append our previous interval because there could be more overlap between this interval here and our next interval. So now we check. Is there any overlap between this interval here and this interval? No. So now we can append our previous interval to our line, and this is going to be stored in a different array. So I'm going to just draw it on our number line as purple. And now we can move our previous pointer to the current and our current to the next interval. So now we check. Is there any overlap with these two intervals? No. So we can just append our previous interval to our number line. And now we're done going through every interval in our array here. And at the end, we can just append this last interval to our result array. And then this would be our final answer here that we returned. And as you can see, there's no overlapping intervals, so it's correct. Our time complexity for this algorithm would be O of n log n plus n. And the n log n is from the sorting, and plus n is from iterating through the intervals list. And this just simplifies to O of n log n. So that will be our time complexity. And for our space, we're storing the new intervals list in a separate array. So the space is going to be O of n. But there's actually a way to do this in place, so there's no extra space needed. So it can actually be solved in constant space, and I'll show you how to do that in the code. So let's get into it. So first, I'm going to show you the O of n space solution, because I think it's a little easier to understand. And to start, we're going to sort our intervals list. So we're going to do intervals.sort, and then next we want to initialize our result array. And this is where we store our new intervals. And now we want to initialize our pointer, previous, and that's going to be pointing to the first interval. And now we can just iterate through the rest of the intervals. So we're going to do a for loop from 1 all the way to the end of the list. And now we want to check if there's overlap. And how do we check if there's overlap? Well, if we check the endpoint of our previous interval, and that's greater than or equal to our current interval at the start, then that means there's overlap. And all we have to do at this point is update our previous endpoint and make that the max between our previous endpoint and our current interval's endpoint. So we're going to do intervals at I at the end time, and that should be it for our overlap. Otherwise, we can just append our previous variable and then update our previous pointer to be equal to the current interval. And then once we're done with this for loop, we can just append our previous variable again, because if you remember, we would be 1 short. And at the end, we can just return our result array, and that should work. So as you can see, this code runs pretty fast, but the space could definitely be optimized. And let me show you how to do that. So this is the concept space solution, and I'm not really going to go over it too much because it's a bit confusing. The biggest difference is going to be this while loop here. Everything inside this for loop kind of stayed the same for the most part, but this while loop is there because since we're doing it in place, we have to pop some of the intervals at the end, otherwise there would be duplicates. For example, if we didn't have this and I ran the code, you can see that this 1518 came up twice because we merged one of the intervals earlier, so that leaves us with an extra spot at the end. And I'll leave it to you guys to go over this code on your own, but if you wanted to know how to do it in concept space, this is the answer. And if we submit the code, we can see that the speed is about the same for the runtime, but the memory is much better since we're just doing it in place. And now I'll go over the O(n) space solution manually. So here I've drawn another example, and as you can see, there's a lot of overlap with this one. So let's see how our code handles this. So to start, we want to have our interval sorted, and I've already done that here, so we can just check this off. And then we're going to initialize our result array. And I'm going to represent the result array just by drawing the number line points here, and we can just verify that later. And then we want to initialize our previous variable to be pointing at 1 and 6. So I've done that here already. So now we can go through the for loop and the rest of the intervals. So let's start. The first interval we're going to be looking at is this 2 and 5 one, because we're starting from the first index. And now we want to check if the previous interval overlaps with the current interval. So let's take a look. Our previous endpoint is going to be 6, and our current interval start point is 2. So they are overlapping. So now we want to update our previous endpoint to be equal to the max between our current endpoint and our previous endpoint. And as you can see, the endpoint for this one would be 5, and the endpoint for our previous one would be 6. So it's going to stay as 1 and 6 for now. And now we go to the next interval, 6 and 10. So now we check if our previous is going to be overlapping with this current interval. So let's see. Our previous endpoint is going to be 6, and our current start point is also going to be 6. So that means there's an overlap. So now we want to update our previous endpoint to be the max between our previous endpoint and our current endpoint. So our previous endpoint is 6, and our current endpoint is 10. So now we're going to update this previous to be 1 through 10. And now we go to our last interval in our list, and we check if there's an overlap. The previous endpoint is going to be 10, and the current start point is going to be 11. So that means there is no overlap. So now we're just going to append our previous to our result. So we're going to have an interval going from 1 all the way to 10. And now we want to update our previous to be equal to our current interval. So now previous is going to be 11 and 13. So now we're done iterating through all of our intervals. So this for loop is done. And at the end, we can just append our previous to our result array. So we're going to have another interval going from 11 to 13. So our result array is going to be one interval going from 1 through 10 and a second interval going from 11 to 13. And that is correct. There are no overlapping intervals and we merged them correctly. If this video helped you in any way, please leave a like and subscribe. Thanks for watching, and I'll see you in the next video.